Hi friends, how are you all doing? Hope you're doing good. Once again, I'm back with another example on using task. So let's get started. Let me open up Visual Studio and create a new project. This time I'm going to be creating a Windows application project because there are certain things with threads and tasks which are really illustrated much nicely if you go for a Windows application project. So I would like to go for a Windows application project. Let me search for Windows Forms. Windows Forms. There we go. We have C Sharp, desktop, and this using .NET framework. So C Sharp, Windows Desktop. I think I should be going for this guy, .NET framework. All good. So C Sharp, Windows Desktop. This all creates a Windows application. So let me create. I think I haven't opened that. That's why I don't have it in recent templates. All right. Let me go create. Click next. Name this application as WinApp using task. Okay. And I'm using .NET Framework 4.8.1. However, this illustration is good for any framework. So if you are using .NET Core, whatever, this will just work fine. All right. Let me click create. Okay, that has created a nice simple form. Now what is the agenda? The agenda is to click this button and then a long running task will be started in the background. All right, so it will get started. And that task is going to be doing some long computation. And once the computation is done, we want the result to be shown right in this level. However, while the computation is in progress, we want some kind of information that should be sent back from the task, and that information should be shown somewhere in the level 2. All right, so you got two labels. This label will show some kind of return when the task completes this job. All right, when the task is complete, it is done, finished doing all its calculation. We want that response to come in level 1. So this is the final level. I should name this as final result. Right, I just want to have some text so that you understand what it is, and I would like to name this level as LBL final result. Right, and I would like this to hold some kind of receive some kind of intermediary results coming out of that thread, okay, or the task. So I'll call it LBL intermediatory result. Okay, forgive me if I've done some spelling mistake. Result, all good. Right, so I like to write some intermediary results. Okay, so that's what will keep coming here, right? And the final result will be shown once it is done completely. And this will start the task. So this is start task, right? And I should name this as btn start task. All good. We are all set. So what will be the task? The task will be something like a calculation from 1 to 100. Let's make it simple. So I double click on this guy and we will start a task. Let us try to create a function, because ultimately a task models wraps up a function, right? A task is nothing but an object oriented wrapper over thread, and also it wraps a function. So let's first create a function that will be calculating everything from 1 to 100, and it will do it after, like, it will do that in slow motion, right? It will do that in slow motion. That's all we want. So let me have this function also return some value. So I say int, that is the return of it, get result. I mean, I should call this as long task. All right, and this will be doing some long task. Maybe I can also provide how long it should go. I like to say, okay, you please count up to 100, count up to 200, whatever. So I can provide some value like count how long it should go, right? I can call it limit or whatever, like how long it should go. And it's very simple. I'm going to be counting from my one, all right, counting from my one all up to this limit, limit, all right, also equating it to limit. And in the process of doing that, we like to introduce some deliberate delay. We want to be delaying things a little bit to spice up things. So we can write like thread dot sleep for around, let's say, after counting every time you want to have some kind of 100 millisecond delay, right? So yep, kind of 1/10 of a second. 100 millisecond is, so sleep always takes time in milliseconds. So 100 millisecond is 1/10 of a second, right? So after every 1/10 of a second, it will go up to its next value, right? So that's what it is. And let it go. Let it actually do some certain calculation. Now the calculation will be something very simple. I'm just going to be adding those numbers. That's it. Let's make it very simple. So int sum equals to 0, and every time it goes through all those limits, I'm going to write sum plus equals to I. That's fairly simple. So I, starting from 1 to limit, I'm going to be adding those sum up, and the sum is going to be created, and this is what is going to be returned. Up to now, there is no threading, there is no task. All we have done is created a function long task or long job. I don't want to name this as task so that it doesn't confuse you. Long work, all right, long work, all good. Now I am going to be loading this long work in a task. How do you do that? Well, it is pretty simple. We first create a task. Task T, all right, equals to new task. But wait a second. This task actually would return something, right? This is something that you should always think, not what it takes, but what it returns. Point out this thing that what it actually returns. If it returns an integer, I should create a task of integer from the very beginning. All right. Task T equals to new task of integer, and then I'm going to be creating a lambda within itself, a lambda expression. All right. So the lambda expression is like, I'm going to be calling this long work, long job, long work, and I'm going to be passing some value. So long work will be doing something, and it returns an integer, right? So this is what will be, so this never takes what will be injected. We can always pass in the value right here. But the thing that is getting returned is also the type of the task. Remember, if it doesn't return anything, we can just make it simple task without any such generic parameter. Like we don't need that then in that case, right? But since we are having a function which returns something, we must create a task of integer. And then I need to pass in something here. I can do something like fixed. I can just pass in, okay, let me do it all up to 100. So it's going to be walking all through 100, and it's going to be returning the data, and that's what it is all for. So I'm basically wrapping this delegate, this entire delegate. This delegate in turn, what it is doing, it is calling this long task, and whatever is the return of this function will actually be the result of this task. If that sounds complicated, don't worry. Just think this is how we need to do it. And then we should be starting the task. So I start the task. But once you start the task, the system will go past and hit this curly braces. It will finish, but we want to be remaining awaiting for the result that this task, that this function returns. This is the reason why we do await on this T. Awaiting means I just want to be waiting, awaiting that whatever will be the return from this long task will be obtained. Remember, if this function is returning an integer, I should also fabricate a variable like int result. All right. Now, what it necessarily does, who starts this task? This task is started by the main thread. All right. And thereafter, the main thread cannot move past this line. The main thread will be will get an instruction to await on this task, while the main thread is also free to do whatever on the UI. So this is the best part of using a task. The main thread is free. It can do all of its housekeeping activities. Also, it is awaiting for this T. There's a little difference between the English word await and await. All right. So if you are waiting for someone, you are dedicatedly waiting for that guy. You are not even looking at anyone. You are waiting day and night. You're not even like doing anything. So it's a dedicated wait. But if you say I'm waiting for something, that means, well, I am waiting for you, but I can do other things while I'm waiting for you, right? I can still get a phone call, I can still do something else while I'm also waiting for you to come to my home. So that kind of thing, that kind of wait is await. So await is still waiting for it, but the main thread who is awaiting is free to do all kinds of housekeeping job. What is housekeeping job? That means if somebody clicks something on the window, somebody drags the window, these all will be addressed by the main thread. So main thread should always be kept free. That's the main thought of threading. Main thread should not be kept tied with a long task. So that is it. And now let me show the result once it is all done. And the result can be shown in the final result. I can actually show this little down. Let me have this final result control down and the intermediary result all in the top, right? That sounds good. So the final result will now receive the value LBL final result or text is this. All right. So we got the data, and by the time when we are executing these lines, we are already in the main thread. So the main thread will get these job or these statements, and it will wait until this task is done with its job. So awaiting is like main thread is awaiting for the thread to complete its task. Okay, so here the main thread is awaiting for the task thread, I mean the thread which runs the task. So I will call it task thread. Okay, task thread to complete and return. While it does, the main thread is still free. It is happy. It can do all its housekeeping job, right? So this is not a strict waiting. This is awaiting. All right. So let's actually run this and show this in action. So let me do one thing. The very moment it starts, or just it starts right here, before you do the awaiting, you can always say because once you do this awaiting, main thread cannot do anything. Before you do the awaiting, you can actually write something here. Usually people will write something here. That's fine. It's your choice. You can write that starting task or running. Okay, running. Or you can just write please wait. You can just write anything. That's up to you. Let me run it and show you how this works. start says running, and at this time you see you can still do all the stuff, right? But you exactly don't know how far it ran, where this counter is, where I mean what this for loop is doing. So, you see the answer is 5050, that's fine. So but all the intermediary eyes, it will be really good if I can find all those intermediary eyes, right? Like 1 2 3 4, how long it goes. So how can we find or we can get those intermediary eyes back to the code, right? Is there any way doing that? Why not? We can do that. Why not? We can definitely do. And for that, we need some kind of eventing system. So you might say that why not? We can just say that we can write to the text boxes right here. So like many people will say, why not? We can just write it straight here. We can, since this is all in the same form, we can say that LBL intermediary result dot text equals to I dot toString, right? We can just write I dot toString, right? We can do that. Can we? Or can we? Let's experiment. If we can do, we get an exception. That's a big bad exception. This exception says that a thread, see, this long work is now running in a different thread. You agree with me, right? Because it's a task. That thread cannot access any control which is actually owned by the main thread. Look at the problem. Cross-thread operations are not valid. It is saying control lblIntermediatoryResult. It was accessed from a thread other than the thread it was called on, it was created on. So that means this is a big bad problem. I think anybody who has done some kind of Windows application has definitely got this exception. You cannot write to a control which this thread don't owns. The thread which was started or the task that was started don't own this UI, okay? Don't own any of the controls in this UI. So it can maximum have a, it can maximum read the controls, but it cannot write to it. That's a big problem. We cannot do that. Then what to do? Is there any way to write down to the controls? Yes, there are ways. There are definitely ways to do that. Now, the best thing I can suggest to you is to actually, to actually raise an event that can be handled by this code. Okay, there are many ways doing that. This is just one of it. Because if you want to take this whole code inside a different class, then you will even not get access to this control. The best way is to raise event, which this long task will intermittently raise, and that event can be handled somewhere here. So let's do that. So let me create an event. Let's create an event. The event is going to be sending you data. So event is always of a kind of a delegate, right? So let's create an event like, let me create an event like, like public, okay, event. We write event like this, event. We can say that, well, this is going to be like like giving out some values to the caller. So maybe I will say broadcast info. I'm just using this word, but no fancy. Broadcast info. And the info, this broadcast info is actually an event, all right? And the events are always some kind of delegate. So you should always write public event and then the delegate that this event belongs to. And delegate is nothing but a function signature. This broadcast info is an event that is just going to be returning nothing but be getting an integer as an input. So this kind of delegates can be thought as an action delegates. Action delegates don't return anything, but however they can accept something. So you can just say action of type int, right? So we are just saying this is an action of type int. Int means what it takes. Okay, if you remember from your primary understanding, there are three kinds of system delegates: action delegates, function delegates, and predicate delegates. So action delegates are those delegates which can just do some task. Okay, they will not return anything. So this first int is saying us that what exactly it is accepting, what it can be passed to. And exactly this is what we need. We need to be broadcasting the information. We will say if this, we have someone handling this broadcast, okay, broadcast info is not equal to null, this is what we write, then in that case, we can just broadcast info. This is an event and we want to pass this I. We are done with it. We are done with it. So broadcast info is not equal to null. That means somebody has handled this event, someone. If anyone has handled this, that guy should be getting an information deep within this task. All right. And now what we should do? We should be handling this event, right? We should just handle this event right here. Now, since we are doing everything in the main UI, we can just write straight away. We can write before we await it. We can just write that the broadcast info plus equals to tab that immediately actually creates a callback function. I can call it anything. Form1 broadcast info. I don't like this name. I can call it anything. Maybe I'll just call it handle broadcast. Okay, handle broadcast. All right, that's good. And now, so that means that information, okay, we are good with that. The information, this guy will now be obtained inside here. Now we can definitely print that in the label. But once again, this function is still called by whom? By this long running function. So this long running function is working in a thread. So this handle broadcast will also work in a thread. All right, because since who is raising this event, so here the event is raised, right? Event is raised. So the event is raised by this particular function, and this function is working in a thread. Tasks are all threads. So this long work is running in a thread. So if it is raising some event, that event handler will also run in the same thread as of this long work. And you have just seen an error that if I try to write this message once again that lblIntermediatoryResult is object.toString, it won't work either. Let me show you up. This will again fail with the same exception. There we go, it failed. Cross-thread operation not valid. So what we should do? We should actually request the main thread or the thread on which this control, this UI has access on. Okay, so who has access on this control? Main thread. So we can't write this code directly. Instead that we will say, Mr. LBL intermediary result control, can you please kindly call a function which is like, so once again I want it to call a function. So that means a delegate. I can pass it anything you want. I can just pass in an action. All right, an action. So an action that is going to be, I can just write a new action, of course. So it's a new delegate, new action, and this action is going to be, okay, once again, it's nothing but this guy. This action is just going to be executing this task. I mean, this work. I'm just going to hold on. I'm just going to be explaining what I say right now. I just need to be writing it, right? So I know this whole sum of code, but you should understand what this does. What we are saying is, Mr. LBL intermediary result label, right? Can you please can you please invoke this particular delegate, right? a delegate wraps a code, a delegate is always wrapping a code. So that's the code you should execute only when your creator is free. So begin invoke is like you want to start invoking this delegate, this work, whenever its creator. Who is its creator? Main thread is its creator, right? So whenever the main thread is free, if it is free, like you are just giving, you are delegating this task to the main thread instead of forcefully trying to write the value into the label's text. You cannot do that, you know it, because if you do that it will fail, it will give a cross thread problem. You can't do that. You can however request this particular control to execute this action whenever its creator, I'm not saying main thread, its creator, we know its creator is the main thread, so we want to delegate that task to the main thread, that is its creator. This is what is known as begin invoke, right? We are done now. Let me show you. I know this is a little bit of advanced, but for those who have got little understanding of thread will understand this without any problem. See, all the intermediary answers are coming so beautifully. Running and finished. You can definitely create a progress bar to make things nice and simple. You can just have a progress bar. Where is my progress bar? PRO. I got it. Yep. So I can just have a progress bar running through. So when the intermediary results were all on, we can just say that not only you do this guy, but you can also populate the progress bar. I can of course initially say the progress bar's value is 0. I want it to, I maximum value, a minimum value is 0. The maximum value is 100. It's all done. You see the maximum value is 100, and yeah, and then and the minimum and the initial value is 0. All good. So I can just say this progress bar, which is termed as progress bar 1. All right. So that is the thing, progress bar 1. Now we can say that not only we want this guy to execute, apart from that, we want another thing to execute. Now we can really have a little, little 2 lines. If you are having 2 lines, you should definitely, I'm sorry, you should definitely uh, have this within curly braces. So it's all good now. Give a curly braces around, put this first task, and then curly braces around. Okay. So new action, that's the code that you need to execute. All right. You are writing to the label, and also I want this value to be shown in the progress bar. So you can just write progress bar 1 dot value is equals to this object. I don't like this object. It was created by Visual Studio. I just want some kind of status code getting returned. Okay, I can just call it intermediary value, int value. Oops. Oh my gosh. It's okay, intermediary value. Okay, so intermediary value, that means I want all those intermediary values to be shown in that level, and also in the progress bar 1. Let me show you how it works now. This is all good. All right, let me show you. Start the task. See how brilliantly it is working. Great. You might ask the question, is it possible to stop the task at any moment? Why not? We can do that too. We can also stop the task at any moment. There we go. We have another button, and we like to name this as stop task, and like to get to the top, btn stop, or you can say cancel the task. Okay, cancel. I just don't want to progress any further. Cancel task. All right, I should also name it as cancel task. It looks good. Cancel task. If you have some idea about threading, you can do thread.abort. You can stop a thread. Aborting a thread can have very undesirable, undesirable effects. But so we are not using threads, by the way. We are using task. Task cannot be aborted that way. What you can do is that you can politely request the task that can you please stop yourself at some point. There is where the concept of task cancellation tokens are coming in. So we can create in the top a task cancellation token, task cancellation, oh, I'm sorry, cancellation token source. Just forget it. Cancellation, oops, cancellation token source. Great. Let me create this new cancellation token source. Let me call it CTS for short. Okay. Now, what we can do is that we can pass the CTS while this task was being created. We can pass this right here, CTS.token, right? There's a reason why we pass it here. Now, I'll be talking, I don't want to make this video long. So we might not have passed this at all. It would have still worked, but we should be passing it here for some reason. So we have passed this here, and now whenever this task is running, we can actually pip into this token. So after every 1000 second, after you broadcast and everything and do the task, you sum up things, after this thing that we have done it, you can actually see if this CTS, the CTS is cancellation requested. You can actually always see if a cancellation was requested. If a cancellation is requested, what you do is just break out of it. So whatever submission was done, you just need to break out of it, okay? So you just kind of broke out. You kind of stopped. So this is what you can do. You can just break out of it. All right. So breaking out is like you are stopping the task. You don't want to move any further. You want to stop the task, right? So that's it. All we can do right now is, what we can do is that, like when we are here, like, okay, we are awaiting for the result and doing all the thing, we can actually also see if the task, if the tokens, we can just write if this CTS token dot is cancellation requested, right? We can also look at that. If you stop the token, the cancellation requested will be true. All we can do is that in this particular cancel task, we can just write CTS dot cancel. That's it. Cancellation is a request. If you have not written this code, then the thread or the task would not have been cancelled. So it is just like requesting the long work to cancel itself to the point where it can. Like it is doing some task, some work, it cannot cancel in the middle, but at least let it gracefully stop whatever it was doing after doing some basic steps. So it cancelled. Cancel is just breaking out of this loop and returning whatever sum was produced this far, right? So you can also, so the very moment it does it, the await returns. The result, whatever result was created will be returned. Let's say it only did the computation up to 1 to 150 and it cancelled. So it's going to be showing up the result of summation from 1 to 50. And you can also look into if the CTS was cancelled, and we can additionally also pop up a message, maybe message box dot show that the task was cancelled. Okay, the task was cancelled. Let's run and see how it goes. All right, start it. It's doing its job nice. See, the UI is all free. I am cancelling it at this point. Cancel. Task was cancelled, you see. And whatever computation it has done, it is just showing me, right? So it is just showing. So that means it has all computed up to 2145. It could not reach much, right? So that was it. Your homework, if you can do, whoever is watching this video, will be to resume this thread by any means. So I want you to complete this. Like if you have canceled it, is there any way to resume it? Yes, of course. Try doing that while I'll be seeing again in a next video. If you like my videos and all, let me tell you that, or you might already know that I am a one-to-one instructor in .NET. So if you or anyone of your friend or anyone interested to get a one-to-one training, feel free to ping me. The description of what will be given in the description box. Thank you so much for being in the session. See you again back again. Bye bye.